This question is taken from Math Problems in Real World Context, published by Cavendish Education. This will be a guide for question 8 on a demand curve. The question shows a demand curve. The demand curve shows how the number of a type of bicycle sold changes with the selling price of a bicycle. Now, as we can see, the demand curve for the bicycle is downward sloping. It makes sense because as the selling price of the bicycle increases, the demand for the bicycle would decrease. Now let's look at the first question. First question requires us to find the gradient of the graph. Now a quick recap. Gradient is the vertical change over the horizontal change, or some of you may know it better as rise over run. You can use the line, pick any 2 points from the line. So I'm going to pick 2 convenient points. The first one would be 0, 70,000. The second convenient point that I'm going to pick is 350, 0. So I'll form my right angle triangle to get my vertical change. So the vertical change actually went from 70,000 to 0. So it's negative 70,000. The horizontal change is actually 350. So I'll be able to find the gradient of the graph. The gradient is thus negative 200. Now the next question wants us to explain what the answer to A part 1 represents. So what does a gradient of negative 200 represent? Now let's go back to look at the graph. It is the number of bicycles sold over the selling price. So a gradient of negative 200 would mean that for every dollar that the selling price of a bicycle increases by, the demand of the bicycle will actually drop by 200 bicycles. So I'll write this in. Writing it down, it represents the rate of decrease in the number of bicycles sold for every dollar increase in the selling price. You can also explain it. An increase of $1 means a decrease in 200 bicycles sold. Let's go on to part B. Let the number of bicycles sold be Y and the selling price of a bicycle be X. Form an equation connecting X and Y. Now from the diagram, I know that I have a straight line graph. So the equation connecting X and Y will be of the form Y equals to mx plus c, where m is actually my gradient and c is the y-intercept. So if you go back to the graph and take a look, the y-intercept is 70,000. The gradient we have found in part A, which is negative 200. So my answer for this will be y equals to negative 200x plus 70,000. Let's go on to the next part. They want us to show that the amount in dollars collected from the sale of bicycles is given by this. Now we have to bear in mind that the amount collected from the sale will actually be the selling price of the bicycle, which is X, multiplied by the number of bicycles sold, which is Y. So the amount collected would actually be X times Y. So S is equals to X times Y. And from our equation in the earlier part, we see that Y is equals to negative 200X plus 70,000. So if I were to expand this expression out, I will get negative 200x squared plus 70,000x. Shown. Let's go on to the next part. A company is developing the type of bicycles mentioned. The total cost of developing such bicycles consists of a fixed setup cost of this amount and a variable cost that depends on the number of bicycles to be developed. The cost of developing each bicycle is $90. So we need to use this information to express the total cost C dollars of developing Y bicycles in terms of X. So my cost would consist of the fixed cost and the variable cost that depends on the number of bicycles to be developed. So the cost for each bicycle is 90 times the number of bicycles Y. So this would be my total cost. Now they want it in terms of X. So I have to substitute the equation of Y in terms of X. And then I will simplify this expression. To get this equation. So the cost of developing Y bicycles in terms of X would be given by this equation. Part 2 wants us to show that the profit earned after selling Y bicycles is given by this amount. Okay, so in part B, part 2, we have shown that the amount collected from the sale of bicycle is given by this equation. In C, part 1, the cost of developing the Y bicycles would be given by this expression. So the profit simply is the amount collected S minus the cost C. So if you write down the two expressions from the earlier part, we will get profit P equals to this shown. Now the next part wants us to find the values of X when P equals to 0. So I will do a simple substitution. When P equals to 0, I will get this. And then I will proceed to solve and simplify this equation. Solving the equation will give me this. So X is either 195 or 245. Now I want you to pause for a moment now to think about what this implies given the context of this question. So X is the selling price of the bicycle. The profit is 0 if I were to set the selling price to be 195, or if I were to set the selling price at 245. Okay, so as X changes, it actually has implications on the sale of the bicycle. So it affects S, how much money you collect from the sale of bicycle, because it affects the number of bicycles that you will actually sell. And X also affects the cost of developing the bicycles. So these two values just give us the pricing, okay, where the profit will be 0 for the company. Let's look at the next part. Alice claims that the best selling price of a bicycle is $220. Do we agree with her? The question gives us a hint and asks us to sketch the graph of this and use it to explain our answer. Okay, so let's start by sketching the graph. So we're trying to sketch the graph of P against X for this quadratic equation. I know that this is a frowny face because of the negative coefficient of x squared. And I also know the x-intercepts, which I have actually found from the part 1. So I know that this value here is 195. This value here is 245. Okay, so the graph should actually go on beyond here. Okay. And I want to find this, the best selling price, which will actually give me the maximum profit. So my turning point over here. So how do I find this? How do I find this selling price? Now we can actually make use of the line of symmetry of quadratic graphs to help us find this mid value. So the mid value is actually 195 plus 245 divided by 2, and we have 220. So this value of X here is $220, and that would give us the maximum profit. So in this case, I will actually have to agree with Alice, because when X equals to $220, the profit is at its maximum. So I include my explanation. Now you can also include the profit that the company would make if we are selling the bicycle at $220. So I just have to substitute 220 into the equation, and that would give me the profit of $125,000.